Hello and welcome back to Leilani Electronics. Before we get into this next circuit, I want to thank you for watching the video. Like and subscribe to the channel so you can get notifications for more videos, awesome circuits I'm working on and building. Be sure to go to the website, www.leilaniElectronics.com. You'll be able to print out all the schematics and programs I got up there. Have fun building them. I hope you like them. Okay, this circuit right here is actually 3 circuits in one. I'm using these photoresistors right here, right here, right here, and right here. I'm going to show you how you can use them to control a voltage output or a current output. It's real simple. Like I said, there's 3 circuits on this board. I just put them all on the same board, to make it easy. So what we have here, this is your digital output. It's going to show you the output voltage with these 2 digits, red or green. I'll show you when I turn on. And I also have it LED readout. 10 LEDs using the LM3914 with this bar graph display. Okay, let's get right into it. I'm gonna turn it on. First, these photoresistors react to light. So when they're in complete darkness, or if you put your finger over them, the resistance goes high. And when you put light on them, it goes low. So I got my flashlight here, and I'll show you how it works. These things don't come labeled. So what I did was measure them each with my meter and wrote on the back with a Sharpie, so I know their values. But they're just like a resistor. You put your leads on each side, measure resistance, and you cover it over. You put your finger over it, and whatever reading you get is the value of that photoresistor. Okay, so I'm going to turn it on. We'll get into the schematic. It'll make a little bit more sense, but I'll show you. Okay. Right now, we are reading this circuit. Where we get? Okay, let's do this. Let's do this guy first. This circuit uses the LT3092, which is a 200 milliamp current regulator. So what you do is you just replace the set resistor with this photoresistor. So we're gonna right now you can see that the LED is on. Again, this is a high brightness LED, which is rated at 300 milliamps, but this part can only generate 200 milliamps. So the data sheet says you can parallel these to get 400, 600, and I'll go over that also. But okay, you see it's kind of not dim, but it's not bright. Okay, see, once I put my finger over it, see how bright that got? And as you go away, it gets dimmer. Then when you completely put your finger over the sensor, it gets brighter. So that's how you control. That's one way to control an output current with this photoresistor. Now I'm gonna get my flashlight out. Just hover over there and it'll get dimmer. See how I got dim? Now it's bright. Okay, the next circuit right next to it uses a LM317 adjustable voltage regulator. So again, all I did was replace the set resistor or set, they call it per the data sheet, with this guy. So I have 2 jumbo LEDs hooked up to them for the output, which is set at 10 volts. And this particular circuit, you can read the output through this bar graph display or this digital display. And right now we're hovering around almost 5 volts. And as you can see, you have 5 bars, which is 5 volt, because this LM3914 is set up as a 0 to 10 volt output. So I got it set up so you could get 1 volt per LED. Okay, now once I cover this sensor up with my finger, see how bright they get? And look, we're reading about 9.2 volts, 9.4. Now I'm only using, I have this designed so it won't go over 10. But if you notice the display, it'll read 0 dot whatever. That's because it's 10. But I'm only using 2 digits because I don't want it to go over 9.9 or 10 volts. So, you'll see it go to 0, but it's 10 volts. So I'll put my finger over there, 9.5. There we go. Now when I can put light on it, you should see it drop to 1 volt. And that's how you can control voltage using an LM317 and a photoresistor. And you can control current with the LT3092 and a photoresistor. Just cool ways, I think. I just got an idea. I did a circuit a couple weeks ago using these guys for timing circuits. So as you can see, as I'm waving my hand over there, covering the light, see how they get voltage. And this guy will get brighter. He'll get really bright. So that's 200 milliamps when I cover my finger over. Now this thing will get brighter if I was to parallel these two. And the last circuit we have is this, I have another circuit, the third one, which is uses op amps to give you, that you can vary the output voltage. So let me get my meter out and I'll show you this one. Okay, so I have my meter set up. This circuit is also set to give you 1 to 10 volts as an output. So right now, I'm just going to measure the output at pin 1. I'm reading about 8 volts. Now as I cover this sensor, it's going to drop to about 2. Should drop to 1, but the resistors, at 20%, they vary a little bit. So I got to get some more precision resistors to use. But when you build the circuit, you'll see exactly how it operates. But this is, this is close enough. Then when I uncover it, sorry about that, I'm getting about 8. It's going to drop to 0. Let me get no, it's going to increase as I put light on it. Okay, so let me get my flashlight ready. Put my flashlight on there. Try to keep that on there. That's not going to work. But there you have it. That's how you can control voltage using the op amps and the photoresistor. So let me go over to the schematic and explain to you how all this works. Oh, also, I put a switch on here. This is a dual color LED display, so I just put that on there so you can toggle it, between red and green. Let me move this out the way. There we go. Okay, so here we have the schematic for these 3 circuits. I just named it CDS current voltage. That's what type of photoresistor we're using. Got them at DigiKey. Okay, here's your power supply. 5 volts using the LM7805. 12 volts using the 7812. Both connected to 15 volts. Okay, we'll go over the LT3092. Okay. Okay, here's our high brightness LED, and here's our set resistor. If you look at the data sheet, the formula to calculate the current is R set, which is 20K divided by R out, which is R10 times 10 microamps. So once you multiply, or I'm sorry, divide 20K over 10 times 10 microamps will give you 200 milliamps. So as you vary this R18, your current goes up and down proportional to, you know, this sensor right here. So, and that's how you vary the output current. You know, you could use this for anything, a fan, LED, I don't know, an alarm. Okay, up to the LM317. I have this one set at 1 to 10 volts out. This adjustable regulator can be, you know, set up to give you anywhere between 0 to 25 volts out. So again, I just replaced the set resistor with this photoresistor. And per the data sheet for this, your output voltage is R17 over R6 plus 1 times 1.25. So if you calculate that, that should give you, it's going to give you about 10.5 volts. Okay, that's your output. And the reason I set it at 10 volts, you know, I just set it to that just for an example. You can set this for whatever you need it for an output voltage. Same with the current. If you put these in parallel, you can get 200 milliamps, 400, 600, 800, or 1 amp. Okay, this goes into your LM34, which is set to give you 10 volts, 1 volt per LED, and that's set by R5. Okay, then that 10 volts goes into voltage divider, which is these two 10K resistors. So it'll give you, anytime it sees 10 volts, it'll give you 5 volts. It cuts the input voltage in half. And the reason I did that, because this A to D converter only can accept 5 volts. So you don't need this portion of the circuit. I just added on her just to show you that you can get two different type of displays to show you the voltage. So this goes into your 10-bit A to D. Your microchip converts it, and this is your display driver. And here's your toggle for your red and green. Okay, here's your bypass capacitors, and this is the voltage controlled circuit right here. You get your 12 volts in. I have this set so the input is always 0.5 volts, and the gain is set at 20. So that way you're always getting between 1 and 10 volts out, because, you know, just for example purposes for this video and this circuit, I just wanted the output to be no more than 10 volts. So, you know, this is a R2 over R1 plus 1, you know, times the input will give you your gain. So this will give you, this circuit right here will give you 1 to 10 volts out, which I just showed you. This circuit will give you up to 200 milliamps, and this circuit up here will give you 1 to 10 volts out also. And that's pretty much it. Yeah, you got your input protection diode down here. These two diodes over here are just to drop the voltage down for these two 7-segment displays. You don't want to put 5 volts right on them. And this D5, this guy up here right here, is to make sure that the input of this A to D doesn't go over 5 volts. Because remember, this is going to give you 10 volts and, you know, maybe 10 to 10.5. And if it happens to go over, you know, you want to make sure that you don't fry this guy right here. Same with D6 and D7. You know, you don't want to put 5 volts right on LED. Okay, I hope you like the examples I have up here. You can print this out over at the website, build it. You can vary the voltage depending on, you know, what you need it for. All you got to do is just change the input voltage for the 317, in the input voltage for the LM1458. So the LT3092, that I just have it set for 5 volts because this LED is rated at 3.8 volts for the white and 3.8 for the blue. I have a blue one. So you want to keep this at 5 volts and just vary the current. So and that's about it. This like I said, this microchip, you really don't need this portion of the circuit unless you want the red green display, and you have your reset and select. So which I haven't programmed. I really don't need them for the circuit, but I'm so used to using them on all my circuits, so I just use them. That's it. I hope you like it. Go to LeilaniElectronics.com, print this out, build it. Let me know what you think. Thank you.